A very good morning to all of you. 8th D, welcome to the physics class. Hope you all are fine, children.
Yes,
Yes,
ma'am.
ma'am. Fine.
Yes, ma'am.
Good. Okay. Belated Happy Children's Day from my side. I wish that you all stay blessed forever and reach and you get a lot of success in your life. Okay. Good. Now, children, in the last class, we discussed about the phenomena of refraction. Yes. And based on it, page number 192. We also discussed it diagrammatically. We understood that when a ray of light, it enters from the air and it travels through the glass and again it comes out, it moves out from the glass, the medium changes and because of this there's a lot of deviation in its path. Yes? And this is what we call and referred to as refraction. Now, there were some phenomena and I told you to go through them. Did you go through them? No, I think. Okay, no answer, that means no. So on page number 193, children, you have some of the phenomenon which are based on the refraction of light and we'll be discussing about them one by one. So let's start with the first one, that is refraction in real life, that is real and apparent depth. Now first you need to understand the term itself is explanatory, self-explanatory, that apparent means something which is appearing and real and actual is something which is in actual sense. So this phenomena generally happens when we see or when we look at the base of the floor of the swimming pool. It happens that it appears to us a little raised. Yes. And actually it's not like that. Generally it happens when we look at the floor of the swimming pool, it appears to us a little raised up. But it is not like that. That is not the actual depth of the swimming pool or the floor of it. Yes. Why this is happening? Let's read about it. Again, children, the logic behind this is refraction of light. What happens now, just look into the diagram very carefully so that you understand, because these examples can be asked, like why it is happening in reasoning based questions. These can be asked, so you have to write the answer. For that you have to understand. So just see that a person is standing, yes, and you have a box. That box is indicating that this is the real depth of the swimming pool. And then you have a box again, a square box, children, which is indicated with the dotted line, and this shows the apparent depth. Yes, the depth that appears to you. Now, why this is happening? Let's read about it. What happens, children? That when the light enters from water to air, from water to air and reaches our eyes, then it bends away from the normal. Why it bends away from the normal? Because when it is moving from water to air, which medium to which medium? Can anyone tell me?
Ma'am,
Ma'am,
denser
denser to
medium
rarer,
to rarer
Very
denser
medium.
good.
to
Rarer. Yes, correct. From denser, it is moving to the rarer medium. And as we know the rule, when it moves from denser to rarer medium, then what happens, children?
it bends
It
away
bends
from the
away
normal.
It
From the
bends
normal.
and
Normal.
gets
Towards
Yes,
deviated
no.
from its
yes,
actual
yes.
path.
It bends away from it. Away or towards?
Ma'am, away.
Ma'am, away
Ma'am,
from
I'm
away.
normal.
Ma'am,
away.
away.
Yes.
Denser to rarer away.
Now you see, yes, now you see that, just follow what I'm saying, that if the ray starts moving from where it is indicated that it is the actual depth, from there it start moving in a straight line. It could, if you just keep, if you have your scale right now, just keep your scale on that line and just see that where that line should reach. But it is not reaching there, it is bending away from that line. Yes, if you just keep the scale on it, you see that it would have traveled a different path, but it has not traveled that path, but it has deviated from its path. And this is because the refraction process has taken place. Now, the one that is reaching our eyes, if you just produce that ray backward means you keep the scale straight on it, and with the help of that scale you produce the line with the help of the dot backward. Where that line goes, children, that place, that point becomes the point which shows you the apparent depth, or where your eyes are actually able to see. Apparently, they are able to see the depth. That is the apparent depth. So you will be able to see it by producing the line backward. So this is happening. This is one of the phenomena which is based on the refraction process. Any problem in this? Anyone?
No, ma'am.
No, ma'am.
Okay.
No, ma'am.
Fine. Now the next one is again based on the same. It is difference between actual sunrise and apparent sunrise. The sunrise that appears and the sunrise that actually takes place. So now you just observe the diagram again, children. You can see a part of the earth. Yes. Then you can see actual position of the sun and the apparent position of the sun. Now can anyone tell me what is the meaning of horizon?
Ma'am, it is looks like a place where earth and the sky meet.
Repeat it.
Ma'am, it is a line where it looks like the earth and the sky are meeting.
Yes, very good. Correct answer. It is a point you can say where they seem to meet. They actually don't meet, but they appear and they seem to meet. Very good. So, the refraction of light through the atmosphere give rise to many interesting phenomena. One of this is this. The sun becomes slightly visible even before the actual sunrise due to the refraction of light by the atmosphere. Now, again, the same thing is taking place, that because of the light entering from the atmosphere, so what happens, that the change in the position can be seen. Sunlight gets deviated as it enters from a rarer medium to the denser medium, and this leads to the appearance of the sun at a position different from its actual position. As you can see, the white rays of light, if you observe the diagram carefully, you can see that actual position is somewhere else, and when it moves from the rarer to the denser medium, we see that there is a deviation, and if you produce the light back, if you produce the ray with the dotted line, you will see that this is the apparent position. Fine. So this is another phenomena, children, based on the same logic. The same happens when the sunset takes place, sunrise and sunset. Third one is the twinkling of the stars. Now when we draw the diagram, when we draw a star, we generally draw it like this. Yes, we show it with the edges, sharp edges, conical edges. Why do we do so? Because the star actually appears to us like that. But it's not like that. Is sun also a star?
Yes, ma'am.
Yes, ma'am.
Yes. But when you draw the sun, you don't draw it like this. Yes. But when we draw the stars, we draw it like that. What is the reason behind it, children? Because they appear to us in that shape. And again, why? Because the light rays, they are coming from far off. And when they travel, there is a lot of deviation in the path of the light. Somewhere it is a vacuum, somewhere rarer, somewhere denser. Yes, all through the way, there is a lot of deviation since the medium keeps changing, and because of that there is a zigzag path which is created, and because of that the stars appears as twinkling. I'm reading it out for you. Before reaching the earth, light comes from the stars, passes through many gaseous media. Now there are different gases. Again, they can be rarer and denser, and they can be vacuum also. What is vacuum, class?
Ma'am, empty
Where
space.
air is also not present.
Yes, empty space where you cannot even find the air. That is the vacuum. So it undergoes refraction many times and its path gets deviated and becomes zigzag. And because of that zigzag, they appear to us as twinkling. Fine. So these are the three phenomena, children. Now they can be asked in your exam that with the help of any three phenomena, explain the process of refraction. So this will be your answer.
Yes, ma'am.
Yes.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
And along with the help of
Yes,
diagram, you'll
ma'am.
be able to write the answer.
Yes,
Yes,
ma'am.
ma'am.
Fine. Okay.
Yes, ma'am.
Okay. So now this is how we have come to end of the refraction. Now we'll be talking about a new topic, and that is lens. What are lenses? You must have studied about a part of a lens in your class 7.
Yes, ma'am.
Was it
Yes,
there in the
ma'am.
syllabus?
Yes, ma'am.
7
Yes,
class?
ma'am.
Yes, ma'am.
Okay, so we'll be studying about it in detail, how the refraction of the light takes place through them in detail in class 8 now. So, yes. So in the previous class, you've studied that lens is a spherical transparent surface. A lens is a transparent medium bounded by two refracting surfaces. So this is important that both the sides, they are refracting, that refraction takes place from both the sides, of which at least one is spherical. So two refracting surface, of which at least one should be spherical. Now, so you can say simply, you can say that spherical refracting surfaces. Spherical refracting surfaces are lenses. They can be made of plastics. They can be made of glass. Now, they can be of two types, children, concave lens and convex lens. Now, to understand and to avoid the confusion, the very first thing that I always tell my children, when you talk about concave, yes, just have a look into the diagram, all of you, concave. Any one, the first diagram, there are three types given. You just have a look at the first one. You can see that here, this type of structure you see. Yes?
Yes,
Yes,
ma'am.
ma'am.
Yes. So you just remember.
Yes, ma'am.
Yes, ma'am.
Yes. So you just remember that the word is formed of two subparts, that is con and cave. Yes. And generally when you draw a cave, you draw a structure like this. So where you see this structure, the cave, that is concave. So it is always easy for you. You never get confused that which one is convex and which one is concave. So this one is concave, having cave, and the other
Yes.
one is convex. Fine. So this is just a simple logic to remember. Then the concave ones, now if we are talking about, we have started with concave, let's talk about concave. The concave one, children, they are thinner at the center. It's all very simple if you just remember its diagram. It's a representation. They are thinner at the center and they are thicker at the edges. So here you have edges, they are thicker at the edges, and in the center you see that they are thinner. The same thing you can observe in your diagram also. Now moving on to the convex one, which are given at the upper side. Here you see that they are thicker. Now here it becomes like this. Yes, so they are thinner at the
Ma'am, edges.
Thinner at the
edges,
edges.
and
And
at the
thicker at
center
the
they
mid.
are,
And ma'am,
Ma'am, they are
and thicker
thicker
at
in
the middle.
Thicker
middle.
edges.
yes, they are thicker
Thicker
at the center, and at the edges they are thinner. Fine. So
thinner.
this is about them, children. Now let's talk about in which varieties they can be found. Let's talk about the convex one. The first one, simple convex lens. Then you have biconvex lens. Bi, children, bidirectional, two direction. Yes. So bi word refers to two. Bi, by two. So biconvex, that means from both the sides it is like this, biconvex. Then plano-convex, children, the third one, that is from one side it is plane and from the other side it is convex. As we have already studied, this is convex and this is concave. So biconvex from both the side, this is the case. Plano-convex, one side plane and the other side curved like this. Yes, so this is plano-convex. Now, the same way if we talk about the concave lens, first is the simple concave lens. Second case you have biconcave. Bi again means two side. Two side, you see that both the sides the caves can be formed. So this becomes biconvex lens. And the third case is the plano-convex, that is from one side it is plane and from the other side you can see this type of structure. Yes, and this becomes the plano-concave lens. So is there any problem regarding the shape of them, children?
No, ma'am.
No, ma'am.
Because see, if
No,
we
ma'am.
would have been there in the lab, in the school, yes, you would have got a chance to touch it, to see it. But since right now we are at a distance, and moreover, when you draw the diagram, let me tell you children, when you draw the ray diagrams, on the paper you don't you don't draw the actual structure, you draw it like this. Yes, so it should be very very clear to you when a question comes based on the ray diagram. The first and the foremost thing is that concave convex lens should be clear in your mind, that what you are using through which you are drawing the ray diagram. So that is why this is important to understand. Fine. Now The two diagrams which are there, children, on page number 193, again given in front of concave and convex lens, we will be doing that. Along with that, we just turn page number 194. You have some terms related to the lenses, which is very important for you to understand, because these terms, when you understand these terms, then only you will be able to draw the ray diagrams, which we'll be doing in next class. So, and there are some terms which we need to understand. There's a table given and we will read the term and we will tally that yes, it is actually there in the diagram or not. Fine. So that these diagrams will also, such they are looking somewhat complicated, these diagrams will also be clear to you. So let's talk about the first one. The first term is optical center. It is indicated by O, alphabet O. And what is it? It denotes, it indicates the center of the lens. So just have a look. See, you will check in both the diagrams, in convex and in concave both, whatever we are doing. So just turn the page now. Can you see the first diagram of the convex lens, children?
Yes, ma'am.
Now can you see the
Yes,
center?
ma'am.
Can you see the center?
Yes, ma'am.
Yes,
The
ma'am.
center is
Yes,
indicated
ma'am.
with the alphabet O.
Oh.
Yes, so this indicates the center of the lens. Again, the same case, look down to the next diagram in concave. Can you see the center indicated with O?
Yes,
Yes,
ma'am.
Yes.
ma'am.
So this,
Yes, ma'am.
if supposing if it is asked if a lens is given and O is written and it is asked that what it is. So what do you write? It is the
Optical center.
Center.
optical,
Optical center.
yes, it is the optical
Optical
center
center
of
of
the lens. Very good. Now,
lens.
yes. Second one is focus or focal point. It is indicated by capital F and it is the point where the ray of light meet or they appear to meet. Now remember the example when you were looking at the floor of the swimming pool. So where the rays meet and where they appear to meet. There can be two cases. Yes. So when they children, very important something, very important, when you produce the rays with the help of the dotted lines, they are said that we have imagined and we have made them like that they appear to meet. And when the rays directly they meet somewhere, they form the this thing, then they are said to be actually meeting. So both the cases, whether it is appearing or it is actually meeting the rays of light, we call that point as focal point or we call that as focus. Now let's see that in the diagram. Turn the page again, children. In the first case, now why it is going parallel in the meeting, that we are going to discuss. I'll talk in the next class. Right now just understand simple things that I'm telling you. Now you could see the first case, through the lens the parallel rays are moving, children, and then after refraction through the lens they meet. Yes, so this place, this point where they are meeting becomes the focal point or it becomes the focus. In the second case, you see that the rays started traveling parallelly, same way, and since it is a divergent length, so the rays they diverged. They were moving parallel, and once they passed through the lens, they diverged. Now here you can see that you are producing the rays backward with the help of your scale and a pencil. You show them with the dotted line and you make them meet. You are making them meet. So you can see that they appear to meet at a point, and that point is called the focus or it is called the what?
Ma'am,
Focal
focus point.
point.
Focal point. And it is indicated with which alphabet?
Ma'am, capital
Capital
F.
F.
Capital F. So
Capital.
is this much clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay.
Yes,
ma'am.
ma'am.
So just
Yes,
do one
ma'am.
thing.
Yes,
Just
ma'am.
do one thing. Take your pencil and just tick optical center and tick focus and focal point. Now, why I'm being so particular about all these little things, children? Because these are the point that sometimes when you miss out, and then when the actual question is given, you are not able to solve it. You are not able to draw the diagram, or rather you are not able to understand what you have to draw. Fine, that is why I am moving very slow. I'm explaining you each and everything so that you understand that what has to be done. So these 2 points have been covered, that is optical center and focus. In the next class, since the time is up, in the next class we'll be discussing the rest of the point, and we will be discussing the rules which we have to follow, that which will help us in drawing the ray diagrams. And again, I have sent a message on WhatsApp that it is important for all of you to attend the class. Now today I'll be seeing that how many of you were there in the class. Those who are not there, I'll be sending the names now, because this is not good if you are not attending the class. Fine. So children, those who have attended, please make sure that you attend the next class, because next class we'll be doing ray diagrams. Okay children. So this is how we have come to the end of today's class. If you find any problem, please send the message on WhatsApp. Till we meet again, take care of yourselves. Bye bye children.
Bye, ma'am. Thank you, ma'am.
Bye, ma'am.
Bye,
Thank
ma'am.
you,
Thank you,
ma'am.
ma'am.
Bye, ma'am.
Thank
Thank you, ma'am.
you.